Electric current and circuit. Learning objectives. Chemical effects of current. Electric current in water. Electric current in a solution. Chemical effects of current. A common misconception about water is that it is a powerful conductor of electricity. It may present risks of electrocution. Let us clear that it is because of the ion of mineral salts and carbon dioxide dissolved in water that make water a good conductor. Touching electric appliance with wet hands. As explained above, water becomes a good conductor because of the ions of minerals dissolved in it. When we touch an electric appliance, say for example an electric switch which might have some moisture already in it, the dissolved minerals in the water on our hand and of that in the switch attract the current and allow conduction. This gives us a strong electric shock. Touching any electric appliance or item with wet hands should always be avoided. We now shall perform certain experiments to show I. Pure or distilled water is not a conductor of electricity. 2. Salts present in water make it a conductor of electricity. And 3. Other liquids that are conductors of electricity. Activity 14.1. Set a circuit with two metal clips X and Y. One end of the material, liquid, is to be connected through a wire with X and Y and the other with a bulb. Close the switch. If the bulb glows, it shows that the material, liquid, is a good conductor. If the bulb does not glow, the material is bad conductor. Observation: when only distilled water, pure water, was used, the bulb did not glow, showing that pure or distilled water was not a good conductor of electricity. Activity 14.2. The same experiment is repeated with a slight difference. Now some salt is added to the distilled water. This time when the switch is closed, the bulb glows, i.e. electric current passed through the salt mixed distilled water, showing that it was the salt that made the water a good conductor of electricity. Pour off the salt solution and rinse the beaker with distilled water. Now again half fill the beaker with the distilled water and add 10 to 15 drops of sulfuric acid to the distilled water. On dipping the bare ends of X and Y, again the bulb lights up. It proves that acid on dissolving in the distilled water makes it conductor of electricity. Similarly, repeat the same activity after dissolving 10 to 15 drops of sodium hydroxide solution in the distilled water. The bulb lights up, proving that the addition of alkali to the distilled water makes distilled water conductor of electricity. Activity 14.3. Now using the same method again, use different materials in place of water, i.e. glass, wood or plastic. In all the three cases the bulb will not glow on closing the switch, showing that glass, wood and plastic are not good conductors of electricity. In order to see which of the liquids are good conductors of electricity, we can do any number of experiments, each time using a different liquid to examine the results. The following results are observed. Good conductors: when salt solution, tap water, vinegar solution, lemon juice and dilute hydrochloric solution were used in the above experiments, the bulb glowed on closing the switch. It shows that all these liquids are good conductors of electricity. Bad conductors: when distilled water, alcohol, kerosene, petrol and mustard oil were used in the above experiment, the bulb did not glow on closing the switch. It shows that all these liquids are bad conductors of electricity. Electric current in water. When electric current passes through water, water does self-ionization, i.e. it decomposes of its own into positively charged hydrogen, H+, ions and negatively charged hydroxide, OHM- ions. The H+ ions get deposited near the negatively charged terminal and O deposit near the positively charged terminal. The H+ ions get charged again to convert into hydrogen atoms and O- lose their charge, H, and form oxygen. Electrolyte. Electric current in a solution. Before we see what happens to the solution when electric current passes through it, let us know about some terms frequently used. Electrolytes. Electrolytes are chemicals that conduct electricity when dissolved in water. These are the substances which conduct electricity because a fraction of their molecules dissociate into positive and negative ions. The positive ions are known as cations and the negative ions as anions. Electrodes. The conducting pieces, rods, plates or other objects, through which the electric current enters and leaves an electrolyte are called electrodes. An electrode is a solid electric conductor that carries electric into non-metallic solids, or liquids, or plasmas, or vacuums. In an electrochemical cell, reduction and oxidation reactions take place at the electrodes. The electrodes connected to the positive charge are called cathodes, while those connected with the negative charge are called anodes. Voltmeter. The apparatus containing electrolyte and electrodes and in which the process of electrolysis is conducted is called voltmeter. Now let us see what happens when an electric current passes a solution of common salt, electrolyte. Common salt, i.e. crystalline NaCl, consists of Na+ and Cl ions bound by electric attraction. The presence of medium, here water, reduces the field by a factor equal to the dielectric constant of the medium between the two charges. This reduces the attracting potential between Na+ and C-, and they get dissociated into Na+ and Cl ions. There are the charge carriers that conduct electricity in the solution. Electrodes. Voltmeter. Activity 14.4. Take a voltmeter with platinum electrodes. The voltmeter is filled with common salt solution and connected with a 6-volt battery and a switch. The voltmeter is filled with sodium chloride solution and the test tubes also filled with sodium chloride solution are inverted in the trough of the voltmeter. Put the switch on, ionization will take place and gases will be liberated. In a short while the solution in the test tubes will give way to the gases entering into the test tubes. The test tube inverted on the anode, minus, terminal will gather twice the volume of the gas as compared to the test tube inverted over the cathode, plus, terminal. The properties of the gases collected in the two test tubes can be assessed by bringing near their mouths a burning candle. The candle will give a bright light near the test tube of cathode terminal identifying O2 gas in it. The candle will go off at once after the gas in the anode side test tube will burn with a slight sound. This proves terminal identifying O2 gas in it. The candle will go off at once after the gas in the anode side test tube will burn with a slight sound. This proves that this test tube contained hydrogen. This experiment shows that water got split into H2 and O3 ions with different charges. Electrolysis. Passing of electricity through the solution of an electrolyte for its decomposition into simpler substances is known as electrolysis. Electrolysis is carried out in an electrolytic cell called a voltmeter. Electroplating. It is the process of coating a metal object with a layer of another metal by means of electrolysis. The electroplating coating is usually up to 0.002 inches thick. Electroplating is used to give the metal object a better appearance or to protect them from corrosion, wear or rust. Tableware, trays, decorative pieces and jewelry are plated with gold or silver to make them more attractive. Activity 14.5. Coating of an element. In a voltmeter, electrolytic cell, CuSO, copper sulfate solution, is filled. Cathode is made of the iron rod that is to be coated with the copper. Anode is made of the copper rod which will lose the copper. The switch is put on when the reaction begins. CuSO4, Cu into 2 plus SO into 4 minus 2. Process. When there is a steady current in the circuit, the following process will take place. Electrons flow from the negative terminal of the battery to the electrode, C, via the connecting wire. The electrode, C, is at a lower potential than electrode, A. Therefore the positively charged ions of copper, anions, move towards A. At the cathode, C, The Cu2 plus ions get neutralized by the incoming electrons from the external circuit. The reduction reaction at the anode is Cu into 2 plus 2e minus Cu. The Cu atoms so produced will get deposited at the cathode ion rod in the shape of a cover. At the anode, the So into 4 minus 2 ions react with copper to release electrons. The oxidation reaction is Cu into 2 plus So into 4 plus 2e. The copper ions get into the solution, while the released electrons flow back to the positive terminal of the battery via the connecting wire. The overall process results in deposition of copper at the cathode while the anode loses an equivalent amount of copper. Flow of charge. The negative charged electrons were not discovered until 1980s. Before that, the direction of the current was regarded as the direction in which positive charge would flow. This convention is still maintained, although it is now known that in a wire the actual movement of the electrons, negative charge, is flowing in the opposite direction. The charge carriers in a liquid are positive and negative ions. When the liquid is placed in an electric field, there is a drift of positive ions in one direction and negative ions in the other. Uses of electrolysis. There are many uses of electrolysis which include electroplating. The electroplating of objects by nickel, silver and gold is very common. The conducting material to be electroplated is made the cathode, negative, of an electrolytic cell, voltmeter. A strip of metal whose coating is required on the cathode material is used as anode, positive. A soluble salt of the same anode material is taken as electrolyte. When the current is passed through the circuit, then a film of material is deposited and the cathode. Extraction of metals. Certain metals are extracted from their ores using electrolysis. For example, aluminium is obtained by passing an electric current through fused bauxite, Ai into 2O into 3, and cryolite, Na into 3F into 6. Active metals like sodium, calcium and magnesium are also extracted from their ores by electrolysis. Purification of metals. For this purpose the impure metal is made the anode, plus, and pure metallic strip is used as cathode, minus. A soluble salt of pure metal is taken as electrolyte. On passing current, the impure metal anode dissolves but only the pure metal deposits on the cathode. Copper is purified by electrolysis. Electrolytic capacitors. These capacitors consist of two aluminium electrodes placed in an electrolytic mixture of ammonium borate or sodium phosphate in glycerin. When a steady current is passed, a thin layer of dielectric aluminium oxide or hydroxide is formed on the anode. Such very thin films can offer large values of capacitance. The most widely known of all uses of electrolysis arguably is hair removal. This type of electrolysis is used for aesthetic purposes. Keywords. Electrolyte, substances which conduct electricity. Electrodes, the conducting pieces through which current enters and leaves an electrolyte. Cathode, the negatively charged electrode. Anode, the positively charged electrode. Summary. Pure or distilled water is not a conductor of electric current. Conductivity of water is due to the minerals and salts dissolved in water. Touching of an electric appliance with wet hands should be avoided. The positive ions are known as cations and the negative ions as anions. Water does self-ionization into H+ and O ions when electric current passes through it. Electrolysis is carried out in an electrolytic cell called a voltmeter. The solutions get dissociated into charge-carrying ions, plus V and minus V, when electric current passes through them. The apparatus containing electrolyte and electrodes and in which the process of electrolysis conducted is called a voltmeter. Electrolysis is a process by which electricity is passed through electrolytes for its decomposition. Electroplating is the process of coating a metal object with a thin layer of another metal by using electrolysis. Electroplating coating is usually up to 0.0001 to 0.020 inches thick. The positive charges flow in one direction and the negative charges in opposite direction when a liquid has an electric current through it. Electrolysis is used in electroplating, extraction of metals from their ores, purification of metal and making electrolytic capacitors.